So we will proceed with from question number 7 today. Sorry, beta. Yeah, I told you that we will do it on tomorrow's class, no? Because I will conduct the one session tomorrow, no? Yesterday I mentioned it that first we will do some more questions of the sampling and estimation, and then we will proceed with the hypothesis testing. What time? Tomorrow? Tomorrow. What is your availability? Actually, that's the main thing. Are you available as early? So when you come back from school. By 7:30. Oh, is there any possibility to get free early? Like what time? Because the thing is, tomorrow I have the workshop, no? So I will be busy from my 8 now. Like my 8:30, my 8:30. So my 8:30 till night I will be busy because it's an online, na? So is there any possibility to be get free before 7:30 of yours? Just like that, for example, my can you available at my 6:30? Is it possible for you? 6:30 for me and 4:30 for you. It will be. Am I correct? So my 6:30 to 7:30 we will take the class. Okay. 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 Just wrote it. Okay. Anita carried out a survey of 150 randomly selected students at her college. She found that 49 of these students watched the TV program called Calculate an approximate 98% confidence interval for the proportion P of the students at Anita's college who watch bunch. Okay. So now what we are going to do? So we have to go for exactly for the proportion things. Huh? So we have to make a confidence interval for that thing, and it is very easy because in the last class we did the last question that was from the proportion. I guess remember it. So over here, when I'm talking about a proportion estimate, it can easily be figured out like it will be 49 by 140. So it will be what? 49 by 140, that is exactly 0.35. Okay, and then furthermore 0.35, and we have to go for the 98% confidence interval. So it means this portion is going to be 98%. Okay, now what is the formula? Like we know that we will be following a normal distribution PS, and at that time what we can say that P estimate NP QS divided by NS is the variance. Okay, So what will be our QS? Like Q estimate is going to be 1 minus 0.35. 1 minus 0.35, it will be 0.61. Yeah, 0.65. And what is exactly the formula for the confidence interval? The confidence interval will be followed by this way: P gap plus minus C under root of PQ over N. Okay, is that fine? So I can proceed with this like 0.35 plus minus Z under root of PQ. So P is 0.35 and Q is 0.65, and N will be what? N will be exactly 140. And they are telling me that a 98% confidence interval. So what value we are going to have at 98%? You still do not have any of the value. So 98% we have to see it from here. 9798 and 2 we did it. And you know one more thing which I have not told you yesterday, I forgot, and I also forgot by myself as well. Like when you are having a 98% confidence interval and you have to just check it from these values now, so you can just pick the closest value as well. You know that closest value, like that is not giving you the 98%, and you always round it to the up value. Like 98% is not over here, isn't it? So you can just exactly pick the 99% of the confidence interval. Okay, you can pick that value whenever you are having this kind of questions. Okay, let's suppose if you are having 97 9, no, it will not change the answer. It will just little bit change, but in the mark schemes and in the examiner reports I have also seen that thing. Like if they are giving you the 98% confidence interval, the value is not given over there. So at that time the examiners told us that you should use 0.99 as well. Okay, so whenever the confidence interval is exactly 96% or 97% at that time, so you can use this value. Okay, fine, because it will be rounded up and you have that value. So the Z value will be what? 2.326. So for 98%, Z will be 2.326. Okay, 0.35 plus minus 2.326. 0.35 and 2.65 divided by 140, and it is giving me 0.04031. So 2.326 multiplied by 0.04031. 0.35 plus minus 0.09376. 0.35 plus 0.09376. It's exactly 0.0, sorry, 0.44376, and 0.35 minus 0.09376. It is exactly 0.25624. Okay. And what they are asking in the next part, Carlos says that a confidence interval from part A is not useful because it's too wide. Without calculation, explain briefly how Carlos can use the result Anita's survey to find the narrow confidence interval for B. So we can proceed with the narrow confidence interval now. To find the narrow confidence interval. So we can just reduce the percent. Sorry, beta. Yeah, they were just telling you, narrow confidence interval P. Explain briefly how Keldos can use the results of Anita's survey to find the narrow confidence interval of P. So we can just reduce the percentage. That's it. Like over here, we are getting the 98% confidence interval, so we can reduce the percentage of the confidence interval. Hmm? Percentage of confidence interval should be reduced. Okay, what is in the next part? Question number 8. I guess this is the easy question. We have solved this kind of question before, no? Isn't it? Should we proceed further? Hmm? Number 8. Number 8. Number 8. I am skipping, so we can proceed with question number 9. Okay, the score on one spin of a five-sided spinner is denoted by the random variable x with the probability distribution as shown in the table. X is over there, probability of x is over there, and all the things are there. Show that the variance of x is exactly 1.2. So we know how to calculate the variance because it is a discrete things they have provided you, know. So we can proceed with the variance. If you are interested to know about the variance, it must be what thing? Yeah, we cannot proceed with it's that is for the ungrouped data. Okay, and not for the expected values. Okay, so the variance of x can be expected x square minus expected x whole square. Yeah, so over here expected x square can be calculated by sigma x square p of x, and expected x can be calculated by sigma x dot p of x. Okay, so 0, 1, 2, 3, 4. It's x, it's px 0.1, 0.2, 0.4, 0.2, and 0.1. X dot px is 0, 0.2, 0.8, 1.2, and 4 into 0.1 is 0.4. And x square of px is exactly square, and this it's going to be 0 square, and this will be 0.2 square. 2 square is 4, it will be 1.6. 3 square is 9, it will be 1.8, and 4 square is 16. 16 into this, it's 1.6. Okay, Ma, can you check the last value? I'm having a doubt on last one now because I did not use the calculator. 0.1. Yeah, it's fine. So the total of this one is going to tell me exactly about the main is zero point 0.2 plus zero point 0.8 plus 1.2 plus zero point 0.4. It's 2.6. 0.2 plus 1.6 plus 1.8 plus 1.6. 5.2. So variance of x is exactly expected x square is 5.2 and your mean is exactly 2.6 square. So it must be 5.2 and 2.6 square is 6.76. Did I make any mistake? 1 into 0.2 is 0.2. 2 into 4 is 8. 3 into 2 is 1.2. 4 into 1 is 0.4. 0.2 plus 0.8 plus 1.2 plus 0.4. Exactly 2.6 now. Did they told us about the mean? Score on one spin of 5-sided spin is generated by the random variable x with the probability distribution as shown. What is this happening? One square is this 4 square into 0.8. 4 square. Sorry, what you got? Oh, 2 square is 4. Oh, that's correct. 2 square is 4. 4 into 0.4 is exactly 1.6. 9 into 0.2 is exactly 1.8. And 4 square into 0.1 is exactly 1.6. 0.2. What you got? What you got, bete? Actually, the problem is that it is a negative value. No? Negative, we cannot take out the square root of negative value. No, it's not a square root. Can you hear me? Can you hear me? Hello? You there? Is it my internet or your internet is having a problem? Is it your internet or my internet? I made a mistake over here. I do not know what. But when I'm calculating it from the calculator directly, na, it is showing me 2. 1 into 0.2, 2 into 4 is 0.8, 3 into 2 is... Haha, there is a problem. It's 0.6 na, isn't it? 3 into 2 is 0.6. There is a problem. So it is 2 square and that will be leading me 5.2 minus 2 square. That is exactly 1.2. So I got that one. Okay. Are you listening? The spinner is spun 200 times. The score on each spin is noted and then mean x bar of the 200 scores is found. Given that x bar greater than a is equal to 0.1, find the value of a. So it means n is very large. So we can directly say that it's a normal distribution, isn't it? Isn't it look like they have given you the question of S1? It's totally look like the question of S1. Don't know how. So the spinner is spin. Okay, I'm just proceeding with this part. So it is n, that is 200, and probability of x bar greater than is exactly 0.1. So and this is the same, the spinner is spin. It's the same question. This part I'm talking about. We have to figure out the value of a now. X bar. What is this happening today? Minus mu. Just a second, let me restart the application. I guess it's uploading the data. Hmm. So it will be a minus mean. A minus mean. What was our mean? Mean was 2 divided by sigma. Sigma was square root of 2. 1 point 1.2 close 0.1, and now we can say that z is greater than that value. A minus 2 divided by under root of 1.2 is equals to 0.1. So according to the condition, you have studied that thing in the normal, that greater than any particular value, it is going to be this portion, which is exactly this one, 0.1. So it is understood that we cannot see this thing now, can we? So we have to check the other probability, which is exactly referring me the left. So for this portion, like this is exactly 0.1. I'm gonna check that one, which is 1 minus 0.1, which is equal to 0.9. So what we are having at 0.9 in the normal table, that is 1.282. So I can say that the probability of z greater than 1.2 0.82, it will be equal to this one 0.1. Okay, so when I compare that one, it must be a minus 2 divided by under root of 1.2 is equal to 1.282. So 1.282 multiplied by under root of 1.2 and plus of 2, it will be leading me a is equal to 3.404. Okay, what, this one? Yeah, it must be giving me the final answer. They were exactly asking about the value of a. Na? Find the value of a. Oh, that is asking about 200 times. Huh? Don't you think that we have made a mistake? It is a sample, na? That is exactly the question of S2. I did not see that thing. That 200. Yeah, we wrong. We just did wrong over here. It must be like this, na? 200. So in that case, the whole thing a minus 2 divided by under root of 1.2 divided by 200, it should be equal to 1.282. So a minus 2 is equals to 1.282 under root 1.2 over 200. So a is equals to 2 plus 0.099. So a will be 2.099. It will be approximated to 2.1. Okay, yeah, I just forgot to write the n. That is a main important thing. They are asking us question, and I was thinking this is a question of S1. They have put it over here. That's why I was just so. This is exactly the difference. Huh? This is exactly the difference, and they have mentioned it. There is spinner head towards them, and that is X bar. They have mentioned it. X bar means like they are talking about exactly the sample. It happens sometimes. Okay, what about this one? Question number 10. Unbiased estimate of the population mean and the variance. It's easy, na? Means the sigma cap and the variance cap they are asking about. We have discussed that thing in the yesterday's class, isn't it? Okay. Now, what about this one? This Sunita has a six-sided die with the faces of mark 1, 2, 3, 4, 5, 6. The probability that a die shows a 6 on any throw is P. Sunita throws the die 500 times and finds that it shows a 6 70 times. Calculate and approximate 99% confidence interval for P. So it means it is exactly the same question that we did in the starting today's class. Yeah, we can skip this one. Just read all the parts, na? First one is easy, 99% confidence interval, and the P estimate can be figured out by which way? Yes, 70 upon 500, and then QS is easy to figure out. NN will be 500. Okay, that's fine. So neither believes that the die is fair. Use your answer of part A to comment on your belief. So the die is fair. How can we figure it out from the confidence interval? Uh, but it is a part of the syllabus. Na? We have to do that thing, isn't it? What to say? Okay, I'm telling you. Like your confidence interval, whatever they are having the value. If you see if the die is fair, so the probability of one part is exactly 1 by 6, isn't it? Every outcome will be. So your probability must be lying in this confidence interval. Okay. Let's suppose I'm just giving you an example. For example, you calculated for P, and what is exactly P? Let me know. P is equals to 70 upon 500. Just you please calculate this one. Yes. So 0.14. Okay, when you calculated the confidence interval, so maybe I'm just saying, like you are getting the value of from 0.1 to 0.2, for example. Okay, the 98% confidence interval they were asking about. Na? So when you see the die is fair, so a probability for the single phase should be the same, means every phase should be having the same probability. Okay, and the thing is your probability must be lying in this range. Is it lying over here right now? When I check the probability of 1, so what it will be? 1 by 6, and 2 is also 1 by 6, and 3 is also 1 by 6, 1 by 6, everything 1 by 6. What is 1 by 6 exactly in decimal? 167. Okay, so it is understood that our probability will be lying in this range, isn't it? So it means we are on the right side. We just have to give this kind of uh, explanation to them. Now, the next part, Sunita uses the result for 500 rows to calculate alpha percent confidence interval for P. The interval has a width of 0.04. So, how is the width? What is the width formula exactly? You have noted it. 2C root. Yeah, everyone is the same. PQ over N. So, you can, by this way, you can calculate the value of Z. Exactly. Okay. That's fine. That will always give us alpha. Okay, in the time in minutes taken by the students to complete the test has a distribution of normal, which is 125 to 36. It means the mean and the variance they have provided us. Okay, question number 12. Yes, find the probability that the mean taken to complete the test by a random sample of 40 students is less than 123. So it means they are exactly talking about less than 123, and they have also told us that n is exactly 40. Okay, so when you will be calculating that your z na, because it's a sample, you understand, you know that very well. So it must be this formula, not that one. X minus mu divided by under root of sigma over the variance, sigma square, sigma over under root of n. Okay, because it is a sample, they have provided you the sample over here. Okay, and it's totally normally distributed. Explain whether it was necessary to use the CLT theorem in the solution of the part. Whether it was necessary to use or not, what is the reason behind that thing? If the n is large, oh, see this. whenever we are having the normal distribution, normal distribution, so it is understood that CLT not applied. Okay, so they were not saying this. It is necessary. They were asking you whether it was necessary. So what you will write? No, it's not necessary because the distribution is normal. Okay, we use the central limit theorem when the distribution is not normal. Got it? So you know the explanation for this part, right? Hmm? And furthermore, 100 randomly chosen adult each throw a ball once. It's an easy. It's an easy. It will be done with the estimates. Okay. I am explaining you these questions because of that. I want you to just do the practice for that thing. Okay. Because in the paper, you never know what kind of question is going to come. So you must know about all the stuff related to sampling and estimation. Okay, beta? Okay. And what about this one? Find an unbiased estimate for the. It's an easy question as well. And in 99% confidence interval, this is easy. You know very well how to do that. 4 random samples were taken at 99% confidence interval. For the population mean was found for each sample. Find the probability that all 4 of these confidence interval containing the true value of mu. Now what we are going to say about this thing? This I am just reading the part C. 4 randoms were taken and 99% confidence interval for the population mean mu was found for each sample. There are 4 samples now. So find the probability that all 4 of these confidence interval containing the true value of mu. Not divide by 4. You know about exactly when I'm talking about a branch probability? Yeah, it will be multiplying with that thing, isn't it? Yeah. So it means there are 4 random samples they are talking about. Exactly. So 4 random sample means like it's a first sample, second sample. So every sample is having a probability of 0.99, isn't it? Because they are having a 99% confidence interval. So it means we are going to multiply 0.99 how many times? 4 times. So it is going to tell you exactly what is going to be the value. Okay. Now just see this question and let me know that how will you define, how will you go for part C? Oh, don't ever just go for the n. They are asking us explain why it was necessary to use the central limit theorem. Hmm. So whenever the distribution is not known, what we will do, we will go for the central limit theorem. Remember it? So over here they did not define the distribution. So now we can say it's approximately normal because when we go for the samples will be approximately normal, but the distribution is not known over here. So when it is not known, we will use the central limit theorem. Okay, is that fine? Okay. Find the probability that the confidence interval part B is wholly above the value of the population mean. It's easy. It's easy. What they are asking exactly? True one, true value of the population mean. Actually, they are asking about the probability, na? So which probability they are exactly focusing on? The tails. That is exactly the confidence interval. Na? So they are exactly telling you that which kind of probability they are talking about. They are exactly talking about this portion, beta. Like this is your confidence interval. Okay, so this probability they are asking about, not both of them, just only single. Okay, and how can you calculate that one? 1 minus alpha. 1 minus, yeah, exactly. Okay, it is the understanding the question of the sampling and estimation is an art. And same thing apply on the hypothesis as well. This is the toughest part of S2. And before that, nothing was tough. S1 was quite easy. Yeah, there is so much English. That is exactly the toughest part. Okay. This is also the same question. How many of this 40 confidence interval would expect to be include the true value of mean of the diameter? So we will proceed with this thing, the probability right over here. The confidence interval is exactly 95%. So 0.95 multiplied by 40. That is exactly this part. And this A part you know very well. How to draw the confidence interval for this mean diameter. That is why I am not discussing which one. This one. It will always be the two tail. Confidence interval will always be the two tail. Okay. One tail test or two tail test, it will be existing in the hypothesis. Okay. And confidence interval will always be the two tail. Okay. Now what is exactly this thing? X is a random variable with distribution. What is it? Poisson. A random sample of 100 values of X is taken. Find the probability sample mean is less than 2.88. Now, what you will do with this? It's confusing. No, I just wanted to do this question for you. Okay, that will be the last question. Okay, then after that, the topic is ended because everything is going to be the same. Okay, but this is the question because we haven't done this kind of question before, so that's why I'm just doing over here. What is going on? Did they tell you about anything like the distribution? Yeah, it's a Poisson distribution. So it means if it is a Poisson distribution, you have to apply the central limit theorem. So what is exactly this thing? Like your mean. Oh, don't know what is happening today. So mean is given exactly that is 2.9, and we can say that Venice is 2.9, and it must be dividing by 100, isn't it? Because the sample size is 100 now. Should I show you the notes? Oh, just see this first. Lambda and lambda over n. Can you see it on my screen? So this is exactly the distribution. Okay, 2.9 and 2.9 divided by 100. Okay, and a random sample of 100 values of x is taken. Find the probability that the sample mean is less than 2.88. Yeah, exactly. And you are going to get the probability of less than 2.88. Na? So 2.88 minus 2.9. Yes, yes, go on, go on. Yes, exactly. 2.9 over 10. 2.9 under root 2.9 over 10. 9 over 100 exactly. because that is the variance. The variance is exactly lambda upon n. It's a sample, na? So it must be lambda upon n. It's this one. Okay. So you have calculated. I'm lagging again. I'm getting minus 0.11744. Yes. No, no, yeah, this is my Z value. Yes, 0.117. And I cannot see that value, so I have to check the probability of 0.117 and then I will subtract it from 1. Okay. So you did it. Sorry, beta. No. Maybe you are putting the wrong value. That's it. Hmm. Yes. It must be giving you minus 0.117. Yes, exactly. Yes, exactly. You will just go for the 1 minus probability of that thing, which is whatever 0.117 is showing on that table of normal, and then subtract it from 1. 0. Maybe it is 0. Because I haven't checked that thing. Okay, that's fine. Can we keep till here? And what about tomorrow that you have mentioned it on the group that we will be